Hello all. I'll be presenting in today's session the paper called A Paninian Framework for Analyzing Case Marker Errors in English to Urdu Machine Translation. Since NLP chair Professor Krishna couldn't attend the conference, so I'll be presenting on behalf of the main author Sharmin Muzaffar and Professor Grishnath Jha. So let's talk about the overview of the paper. So the paper has been divided into 4 parts, essentially about the Paninian grammar, then the PG dependency analysis of case marker errors, and proposed algorithm and architecture of the Karka parser, and finally the conclusion. In the abstract, it has been argued that Panini's Karka theory is solely based on the syntactic co-semantic approach to understanding natural language, which takes into consideration the arguments of the verbs. And along with it, it provides a basic framework for exhibiting the syntactic relations among constituents in terms of modifier, modified, and semantic relations with respect to karaka and vibhakti, semantic role and postposition in syntax. So, in this paper, it has been argued that Paninian dependency framework can be considered as a kind of correct theoretical framework for analyzing empty errors with specific reference to case markers. Firstly, a corpus of approximately 500 English sentences from the ILCI domain has been applied as input, and they are provided as input sentences to Google and Bing empty platforms. As you know, Google and Bing empty platforms have already Urdu and Hindi. Thereafter, all the output sentences in Urdu have been collated in bulk. And thirdly, all the sentences have been evaluated and errors pertaining to case have been categorized based on the gold standard. Finally, a Paninian dependency framework has been proposed for addressing the case-related errors for Indian languages, and specifically for Urdu in this paper. Introduction. The rationale for choosing Paninian dependency framework is that Indian languages like Urdu, Hindi, Telugu, Bengali, Odia, and many others are morphologically quite rich and have relatively scrambling word orders which are quite flexible in nature in comparison to European languages like English, German, and so on. Linguistically, Urdu and English have divergent features. The reason is that Urdu and English belong to different language families and have divergent grammatical and semantic structures. And Indian languages have free word order, and above all, they have different cultural backgrounds. One of the divergences is that English has prepositions in prepositional phrases, while Indian languages, Urdu, have postpositions in postpositional phrases. Right. So, if you take a look at these examples from A to D, Zahid Nazm Padta Hai. So it has a kind of SOV pattern so far as the word order is concerned. Similarly, the second one, Nazm Zahid Padta Hai, which is object, subject, verb, word order pattern. Similarly, is in the C, the example Nazm Padta Hai Zahid, which is object, verb, subject ordering. In the final example, in the final instance, Zahid Padta Hai Nazm, which is SVO. So the standard or the unmarked word order is SOV so far as Indian languages are concerned, within which Urdu also comes. But all these word orders are quite acceptable in Indian languages along with Urdu. Out of these above instantiated, for example, word orders, exemplary word orders. The first one is the unmarked, whereas the rest of the following are marked and acceptable in Urdu. The first instance shows the enriched morphosyntactic information, PNG and TAM, encoded in different grammatical categories of the sentence. So PNG is person, number, gender, and TAM is tense, aspect, mood. The dependency tree, which accounts for all the instances, is as follows. For example, the verb is considered to be the root of the sentence, and Zahid, which is the nominative agent or the direct agent, is annotated as K1, while the patient per se, or I would say the accusative object, is annotated as K2 in dependency in Paninian dependency framework. So in the dependency tree above, the agent of the action padta hai is Zahid. So action is padta hai, while Zahid is the agent and the patient is Nazm. So the tree accounts for all the four examples, as you can see, from A to D. So Paninian dependency is quite beneficial for the scrambled languages, or the languages which allow scrambling as a kind of syntactic process, as a kind of syntactic feature. Furthermore, some of the acceptable grammatical and semantically well-formed English sentences translate into Urdu wrongly. For example, the shop sells well is a perfectly grammatically acceptable sentence in English, while dukaan achhe se bechta hai, which is a literal translation of the example 1, is appearing to be a wrong translated sentence in Urdu or in Hindi. So the appropriate English in the above sentence maps into Urdu counterpart quite wrongly. For the sentence to be semantically well formed, the agent has to pass the subjecthood test and needs to have the global semantic features like plus animate or plus human encoded in Urdu. Therefore, it is important and pertinent to experiment with the Paninian dependency. Second, Paninian grammar. So the Paninian grammar considers language as a medium of communication and the information as central to the study of language. The speaker, as an encoder, expresses his ideas through language string, and the hearer decodes the information encoded in the communication to understand the meaning. So Paninian grammar solely deals with the process of communication and provides a theoretical framework to model and extract the semantic information encoded in the process. For example, Paninian model has 4 levels. First one is the surface level, then the vivakti level, then the karaka level, and finally the semantic level. So whatever written in the form of a sentence is at the surface level, and when we go upward to the vivakti level, then it is at the second most level. Then the third one is the karaka level, and finally the semantic level. Whatever the speaker has in mind are semantically understood well. Right. So then let's talk about the karaka theory. So the PG framework, or the Paninian grammar framework, has 2 major levels, the karaka and vivakti. So the former suggests the relation between the verb and the other nouns in the sentence, whereas the latter denotes the local word groups based on case endings, prepositions, or postpositional markers. The karaka relation is the syntactico-semantic relation close to the thematic relation, which is reflected in the surface form. Case markers for nouns are generally the case endings and postpositions, while for verbs are the time features encoded in the auxiliaries. So there are 6 karaka relations broadly considered for Indian languages. Therefore, I have taken 6 main karaka relations. They are the agent or the nominative case, then the karma, the patient, or the accusative case. So karana, the instrument or the instrumental case, sampradana, the beneficiary or the dative case, apadana, ablation or the ablative case, and adhikarana, the locative case or the locus. So In Urdu, we have either no marker or the marker absent for agent or for nominative case, or when there is perfective aspect in a sentence, we have ne with some conditions. So karma, patient, is ko or a default marker, or there is no any marker. Then for karan or instrument, se or dwara. For sampradana, beneficiary, we have ko. For apadana, we have se. Apadana means source, or yeah. And adhikarana is location, me or par. Identifying karakas. So we have taken three kinds of verbs, especially for identifying different karaka relations. They are intransitive verbs, transitive verbs, and ditransitive verbs. So as you can see from the table, so default karaka chart for intransitives. So for karta, there is no any marker or no any vibhakti marker, and it is mandatory. For karma or patient, in an intransitive sentence, either ko marker, vibhakti marker, or default, and it is optional. So karma is optional here. Then adhikarana is the locus, map, or this is also optional. So thus in the example Zahid daudta hai, the verb is in the imperfective aspect, represented by ta and tha, refers to the features third person masculine singular past. So the default karaka chart for this above instantiated sentence is as follows, as I have already explained. Then the transitive verbs. With regard to the transitive verbs, it can be stated that they ought to have karta and karma mandatorily. So both this the presence of agent and the presence of patient in a transitive verb is mandatory, while the instrument and locus both are optional. Similarly, in the instance Zahid ne kahani padhi, the agreement is licensed in the verb by the object because of the perfectivity and transitivity. This information is represented by the default karaka chart as follows. The default karaka chart for a transitive sentence with ne, or you can say, in other words, the transitive sentence with a perfective aspect. So mandatory are agent and patient, and optional are instrument and locus. So the transformation from the nominative to ergative and nominative to dative subject can be represented by the karaka chart transformation as follows without preparing any further default karaka chart. For example, the term features e, r, ya, and g are for the perfective sentences with transitive verbs, where ne is attached to the nominative agent, and the time features na pada, which is the dative subject with the infinitive endings na pada, will have the vibhakti marker ko, se, or dwara with the nominative agent. Then ditransitive verbs. So the ditransitive verbs in the perfective aspect will have the following karaka chart, where there are three arguments of the verb and all are mandatory. For example, karta, karma, and sampradana. So agent, patient, and the beneficiary of the action all are mandatory and quite important, while the other cases like instrumental cases, locus, are optional. So sorry. Then the annotation labels used in this particular annotation process for PG dependency parsing. So the annotation labels are K1 for karta, K2 for karma, so K1 for agent, K2 for patient, K3 for instrumental case, K4 for beneficiary or dative, K5 for source, then K7T for temporal location. For example, the book is on the table, so किताब टेबल के ऊपर है. So there we will be having temporal location, source, special location. So K1 as noun complement, K2P destination, PK1, MK1, JK1 causa, mediator, causey, and RH is cause, RT is purpose, RSP is duration, ADV is adverbial manner adverb, POF is part of complex predicates like conjunct verb and compound verbs. So CCOF is conjunction, FRAC-OF is fragmentary examples. So the PG dependency analysis of case markers errors. The third part is on how we have analyzed different kinds of case markers in English to Urdu MT platforms like Google and Bing. So in the Karta-Karaka relation, the Karta agent is the most independent participant in the action, and there is no overt case, right, for this Karaka. In other words, the Ashraya, the locus of activity, resides in the Karta, and thus there is one semantic role assignment, and the verb is intransitive. So in the sentence 1, as you can see, there is only one argument of the verb, right? So the pronominal I, for example, मैं सो रहा हूँ. So sleeping needs only one argument, and hence it is intransitive in nature. The default Karaka chart for this Karaka relation can be related to to the chart made above table 2 as outlined above. The Karta is mandatory while others are optional. So then, moving on, Karma, Karaka or accusative case. When the Ashraya of the result is different from Karta, then it is called Karma. A verb which has Ashraya of activity and result can be different is called a Sakarmaka transitive verb. Sakarmaka or transitive verb. And the intransitive verb is called Akarmaka because it doesn't have a karma or per se an object. In the sentence 2, there are only 3 arguments of the verb, as you can see. So Shumela ne Rahim ko ek kameez दे दी. So in both Google and Bing platforms, the translation outputs are wrong as the irrogative and dative markers are missing. To predict the case markers, one has to analyze the verb and term features. The verb is dena and the term is dedi, which can be applied to intuitively predict that the verb takes more than one argument definitely. So the Karaka chart for the sentence can be pertained to the chart for transitive verb, where the Karta and Karma are mandatory, but the others are optional. Therefore, the Karma Karaka will get the role of the patient of the action, which is the direct object, and the shirt Shumela has given Rahim a shirt. Yeah. Then moving on, Karana Karaka or instrumental case. So this Karaka is otherwise known as instrumental case, where the Vyapara activity of the karma or result is immediately achieved. In the sentence 3, आप खाना चम्मच से खाइए. So the arguments of the verb such as karta, karma and karana will be mandatory, whereas others are optional. Similarly, Sampradana Karaka or dative case. So in this particular case, the most important thing is that the dative object, which is the beneficiary of the action. For example, Shumela ne Rahim ko shirt di. So Rahim, which is getting the dative object role, having the case marker ko, is quite important than any other argument. So and this is transitive I mean a ditransitive verb, it takes more than one argument. That's why. So similarly, we have apadana karaka or ablative case. So um, in the example, उन्होंने ख्यालातें कंपनी से चोरी नहीं की. So I mean he hasn't stolen any idea from his company. So apadana karaka refers to the abolition or separation of the participant in an action. So in the sentence, the company gets the apadana karaka, which requires a karta, karma, and an apadana mandatorily, while the others are optional. Both the platforms have correctly translated the English sentence. He did not steal, or he hasn't stolen all those ideas from the company. अधिकरण कारक और लोकेटिव केस. So सूरज मगरिब में डूबता है. So the sun sets in the evening. It refers to the locus or the temporal or special location of karta or karma. So as you can see in this example, the verb will take two arguments. One is the karta and the other one under the adhikarana karaka phrase. So these are the different examples related to different cases on Google and Bing, and as you can see, so these are the English input sentences, and these are the outputs from Google and Bing in Urdu, and these are the correct sentences or the gold standard. So let's talk about how we can resolve these different kinds of case markers errors germinating from both these outputs from Google and Bing. So first of all is when an encoder provides an input sentence. So the input sentence will be analyzed by a morphological analyzer. So, for example, different morphosyntactic features like tense, aspect, mood, and person, number, gender, and besides that, the inflections and derivations all are to be captured by the morphological analyzer, and the morphological analyzer will analyze that input sentence. And after that, after analyzing the input sentence, the local word grouping will be done. For example, when there is a case marker, then the case marker is a kind of identifier of a particular group of words. For example, राम के भाई के पिता will be a particular NP chunk or a group or a local word group per se in NLP. Then what will happen is that after being grouped, the sentence will come to the demand words and the source words, and the source words will go to the default Karaka chart as we have already discussed, and the default Karaka chart will try to find out which part of the sentence is necessary and which part of the sentence is not necessary. So which part is mandatory and which one is optional. Then after that, it will try to create different it will try to go to the tables which contain transformation rules for these cases. And then there are three different conditions. If a mandatory Karaka role is one word, then if it is yes, then the transformation rules. After these transformation rules, the parser will provide the output in here. Then after this, if the mandatory Karaka rule is of one word, and it is correct, then yes, then this is the final output. If optional character role is of one word, and if the output is yes correct, then it is the correct output. If the one word is equal to one character role, then it is also the correct output. If not, then all possible answers will have to go to this condition, like for example mandatory character uh, and one role. So the mandatory character will have one role at least, and then it will go to the end or the final passed output. Then conclusion. So in this paper we have discussed uh, the errors pertaining to the case markers in English to Urdu MT web-based platforms like Google and Bing. So it has been observed from the empirical data that sometimes the statistical MT platforms fail appropriately to have some of the case markers. So linguistically we have proposed a parser which is based on Paninian dependency grammar for the identification and resolution of Karaka Vibhakti case markers errors. So computationally, we have further proposed an architecture of a parser based on the PG dependency for the automatic identification and passing of semantic roles and postpositions. So these are the references, and thank you so much. Thank you.